Good day to you all students. I am Taylor S.Adebayo, and today we shall continue from what we started last week on particulate nature of matter. The content that we shall be discussing are the crystal structure of matter, the crystalline and amorphous substances, the three states of matter, and photons. Basically, we shall be starting with the crystal structure of matter. A crystal is a solid matter that has definite melting point and definite characteristic shape, irrespective of the size. Any matter, any solid matter that has a definite and exact melting point and shape, regardless of the size of that matter is called a crystal. Don't forget, I once told you that what we use to determine the purity of a solid substance is the melting point, because a solid melts and a liquid boils. So, a crystal is a solid matter that has definite melting point and definite shape, irrespective of the size. So, in any crystal, the atoms, molecules, or ions are arranged in a definite repetitive pattern or lattice. Substances which have the same crystalline shape are said to be isomorphous. Any substance that have the same crystalline shape, I told you that the crystal solid having definite melting and size, definite melting and shape rather, irrespective of the size. So there are some substances that have the same crystalline form. They appear in the same shape in the crystalline form. Such substances that have the same crystalline shape, they are called isomorphous substances. This implies that crystalline substances exist in different shapes. Okay, you can hear that. Crystalline substances exist in different shape, but crystalline substances that exist in the same shape is referred to as isomorphous. So when we have any two or more crystalline substances that exist in the same shape, they are being called isomorphous. But crystalline substances generally, most of them exist in different shapes. For example, sodium chloride crystals have cubical structure, and other crystal shapes are prismatic and octahedral shapes. Look at what you have here. This first one is what we call let me see if I can have a pointer here. Let me see if I can have a pointer. Excuse me. Okay. Now, this one is what we call cubical structure. Cubical structure. That is exactly what we call that one. This one is exactly what we call prismatic structure. This one is a prismatic structure. This one is what we call octahedral structure. These are crystalline structures. An example of a cubical structure, you can see this is a cubical structure. Example of a cubical structure is sodium chloride. That's example of a compound that exhibits a cubical structure. Sodium chloride exhibits a cubical structure. An example of the prismatic structure, this must be an example, is copper. This is supposed to be copper 2 tetraoxide. This is copper 2 tetraoxide. Please note this should be an omission. So a copper 2 tetraoxide exists in prismatic crystal structure. And the last one that we are having there is the, what do we call it? Is the octahedral structure. An example of octahedral structure is an alum. Alum is an example of a particular compound that exhibits octahedral structure. Excuse me. Let me see if I can just get this right. Okay. Yeah. So let's go ahead. The basic unit of a crystal is called unit cell. That is the basic unit of a crystal. This might look so strange to you all, but I want you to just watch this video over and over. You understand? The basic unit of a crystal is called unit cell. That's the basic unit of a crystal. Unit cell. All right. If these unit cells are packed up and down, side by side in all direction, a cubic lattice will emerge. So when we have all these basic units combined together, packed together, we will have what we call cubic lattice. A cubic lattice, we call it cubic lattice. The atoms or molecules or ions are placed at the corners. They are placed at the corners. Excuse me. Atoms and the molecules of ions are placed at the corners of the unit cells, stacked side by side, up and down like building block. Just the way we build blocks in the house. That's where these atoms are being packed together to form that crystalline structure. This is the structure of sodium chloride. In sodium chloride crystal, the atoms of sodium and chlorine are arranged such that the atoms take alternate position in cube. That's why we call it a cubic crystal structure. Each atom within this crystal has 6 immediate neighbors. 6 immediate neighbors, and the chloride ion are larger than the sodium ion, since their charges are opposite. So they are held together by strong electrostatic force. This is an example. Basically, this is an example of a of a cubic structure of sodium chloride. This is a breakdown, the way it actually works. This is an example. This is a typical example of that. Okay. Now, other types of unit cells are face-centered. We have face-centered FCC cubic cell. We have the body-centered cubic cell and the likes. Now, under the face-centered cubic cell, the crystals are very identical in nature. Face-centered cubic crystals. The body, the crystals that have identical atoms at each of the corners and different atoms or ions excuse me, at the center of each of the faces as shown in the zinc sulfide. This is an example of a face-centered. A face-centered have identical atoms at each of the corners and different atoms at the center of each of the faces. That's the difference between that and the normal cubic center. And in the body center cubic crystals, you have a body center cubic crystal. The crystal that fall into this category is chromium ion and platinum salts. In these crystals, the unit cell has identical atoms at each of the corner and one different atom at the center of the unit cell. One different atom. That's the difference between body-centered cubic crystal and the face-centered. In the face-centered, they are identical at the corners and the ions at the center. You look at it, I said this are identical at each of the corners and different atoms at the center of each of the faces. Different atoms at the center of each of the faces. But in the body center, they are identical at the corners and one different atom at the center of the unit cell. So that is the diagram. Oh, sorry, the diagram is missing here. I will send the something to you during the course of the. And let's look at what we have. Learn so far now. What is a crystal? You must be able to define what is a crystal. What is a crystal? We can quickly go. A crystal is. Look at it. This is where I define a crystal. This is it. A crystal. Excuse me. Okay. A crystal. This is the definition. Is a solid matter that has definite melting point and definite crystalline shape, irrespective of the size. That's the definition of the crystal. Let's go back to the question. The question is, what is meant by crystal lattice? You know, I told you that crystal lattice is from when we have, I think let me just scroll down there and let's see where that is. You can accept the basic unit, excuse me, the basic unit of a crystal is called unit cell. And if the unit cells are packed together up and down, side by side in all direction, a cubic lattice will emerge. That's what we call lattice. It's the arrangement of the cells packed up and down, side by side in all direction. We just want to show you the difference between body center, cubic, crystal, and face center. That's exactly what I explained last. I was trying to show you. The one is the one different at the corner. The one is all different. Just try and check the materials. I will send you the details of this work to you as well after the video in your WhatsApp platform, on your WhatsApp platform. Now let's quickly discuss non-crystalline or amorphous substances. You know, I said that some substances are crystalline in nature, and that's why we define when they are being arranged in a crystal lattice. They are crystalline. So if we then have a non-crystalline, that is an arrangement of substances that do not follow crystal lattice. We have non-crystalline or amorphous. That's another one. Non-crystalline or amorphous substances do not have definite shape. You know, we said that crystalline substances have definite shape. Do not have definite shape because the atoms are not regularly arranged like that of crystalline substances. So any substance that do not have definite shape, you know, crystalline substances have definite shape and a melting point, a fixed melting point. A non-crystalline or amorphous substances do not have definite shape because their atoms are not regularly arranged like that of crystalline substances. These substances behave more like liquid than solid. You know, we said crystalline substances are more or less solid materials because of the melting point we are talking about, and the non-crystalline or amorphous substances, they behave more like solid than more like liquid rather than solid. An example of the non-crystalline substances include the glass, plastics, tar, and so on. The molecules of these substances are long chain and are intertwined in the liquid state as shown. This is the way they are. This is the way non-crystalline substances are, the chain-like molecules of amorphous or non-crystalline substances. That's exactly that. Now, note, crystalline substances have high melting points because much heat is required to break the strong intermolecular force binding these molecules together. That's all about that. The heat required to break the strong force intermolecular force binding them together is very high, and that's why they have the high melting points. Let's quickly look at the differences between amorphous and crystalline substances. Now, the table shows the serial number crystalline substances and the amorphous substances. The first one, number one, the crystalline substances have definite shape, just like what I've told you, and amorphous substances have no definite shape. We have known that. We have learned about that. Second one, crystalline substances have definite and high melting points, and the crystalline substances have no definite high melting points. The melting point is infinitely indefinite. The third one is that crystalline substances are usually soluble, and non-crystalline substances are not usually soluble. Soluble means that they can dissolve in water easily, just like when you put your salt in water. You see that the salt dissolves in water. Next is that they are either hydrated or anhydrous. After talk about this, hydrated means it contains water, anhydrous means it does not contain water. So the crystalline substances can either be hydrated or anhydrous, while amorphous substances can either they are all anhydrous, that is, they are all containing water. The fifth one is that crystalline substances or crystallization takes place when melted, and crystallization never takes place when melted. That is, when we melt amorphous substances, it does not crystalline. And when we melt crystalline substances, the crystallization takes place. Let's look at the third one, which is the state of matter. We know that matter exists in three states, and we have solid, liquid, and gas. In the solid state, molecules are closely packed. The molecules of solid are very, very closely packed and held together by strong intermolecular force. And the molecules do not move because they have that strong intermolecular force, and that's why they vibrate about their mean positions. This accounts for the reason why solid have definite shape and do not move easily. So molecules of solid are very close to packed together. It's as if they have about 1 million people in a small room. We put them together, packed together, they are jam-packed. And the force that binds one molecule to the other is very, very strong. So that's why molecules of solid do not move about. They can only vibrate about their mean position. And this is the reason why solid do have definite shape and do not move easily. In liquid, the intermolecular distances between forces or the intermolecular distances between one molecule and the other is not as stronger as that of the solid. The molecules are held together by force, which is not as stronger than that of the solid. So for this reason, molecules of liquid can still have some degree of movement. They can still move. That's why when you pour liquid on the floor, they can move, they can flow a little bit, but not that of solid, because solid cannot move at all. So the body reason, molecules have some degree of freedom to move. This is the reason why liquid move and change its shape easily. And in gaseous state, the intermolecular distance between one molecule and the other are very far. The gaseous are far compared to the liquid, and liquid are also far compared to the solid. So in the solid, they are most packed. They are not far. They are very closely packed. Liquid is very loose. It's almost loose. And while in gases, it's extremely loose. The force of attraction is also weak here. The force of attraction that bonds the molecules together in gases are very weak. And that's the reason why molecules of gases can move freely than that of the liquid. So kinetic energies of these molecules are greater than that of solid and liquid. That is in gaseous form. This is why gases move fast and randomly. The table below gives the characteristics of the three states. Look at them. Solid have definite shape. I've thought about that. Liquid have no definite shape. They take the shape of their container. When you put a liquid into a container, they take the shape of that container. And gases have no definite shape. Now, the second one is that solid have fixed size and volume. Liquid have fixed size and volume, but gas have no fixed size and volume, but spread easily and occupy the volume of their container. Third one is that solid don't move easily. Liquid can move easily, and gas can move faster than liquid. The last one is that the molecules are closely packed and held together by strong intermolecular forces. I told you that under solid. And the intermolecular distances are greater than that of the solid. That's for the liquid. But the intermolecular forces are weaker than that of the solid. Now, for the gases, intermolecular distances are the fastest, and intermolecular forces are weak and negligible. For solid do not mix with other solid easily, and liquid may mix or not, depending on that liquid, and gas mix easily with other gases. The solid are compressible. You can compress solid. Liquid are incompressible and gas are incompressible. Now, these are examples, these are evaluation questions that we need to know. What's the distinction between crystalline and amorphous substances? Now, I've talked about crystalline substances and I talked about amorphous or non-crystalline substances. Now, you're able to differentiate between the two now. You have to give examples or characteristics of solid, liquid, and gaseous substances. Draw the crystalline structure of sodium chloride. So these are also some assignments you can read about against our next class. I want you to read about surface tension and viscosity. Read about surface tension and viscosity. And then you must be able to answer the questions here before our next class. Thank you for your audience. God bless you. We shall be meeting in our next class. If you have any question as regards what I've explained, just quickly put them through the WhatsApp to me, then I will answer. 2, subscribe to this channel so that any video dropped, you can have the notification on time. Thank you very much and God bless you. Have a blissful week.